Okay guys, so let's discuss the JEE main pattern exercises for the chapter differential equations. The first question is that the differential equation of all parabolas whose axis of symmetry is parallel to x-axis is of order what? So over here you need to understand that parabolas whose axis of symmetry is parallel to x-axis have a general form of what? They are represented in general by x equals ay square plus by plus c. Now the moment you have the equation of any parabola whose axis of symmetry is parallel to x-axis, you can very easily see that a, b, c are three independent constants, and therefore in order to get the differential equation, you will have to 3 times differentiate to basically eradicate the 3 independent constants, and that is going to give the degree to the differential equation to be 3, right? And therefore the answer directly is 3. You don't need to evaluate the differential equation, no, you don't need to do that. Just remember the concept about independent constants. Those many times you will be differentiating to eradicate these constants, and that is going to give you the very degree. Next question says that the solution of the differential equation, now there is a differential equation given to you and the question is to compute its solution. So let's do that. Dy by dx is equal to x square plus y square plus 1 upon 2xy. I can write this as 2xy dy being equal to x square plus 1 plus y square dx, right? Now see, this is 2xy dy minus y square dx equals x square plus 1 dx. Try to recall the formula of d of y by x, right? What was it? It was x dy minus y dx upon x square. Similarly over here, if you try to create the pattern, this is 2y dy, which is actually d of y square minus y square d of x equals x square plus 1 dx. I want an x square over here in the denominator. If I divide both sides by x square, I get this upon x square and I get this upon x square. This becomes what? X dy minus y dx whole upon x square is d of y by x. Y is replaced by y square, you get d of y square by x. This is equal to what? 1 plus 1 by x square dx, or I can write it as d of x minus 1 by x, right? D of x minus 1 by x is nothing but 1 plus 1 by x square dx. Again, when you integrate both sides, you obviously get y square by x equals x minus 1 by x plus the constant of integration. And over here you get y square equals x square minus 1 plus cx, which you can write it as x square plus cx plus c by 2 whole square minus 1 minus c by 2 whole square. I am just completing the square. This is x plus c by 2 whole square minus 1 minus c square by 4. This obviously is representing a hyperbola, and therefore the solution is basically a hyperbola. Clear? That's how easily, just by the usage of this particular formula, that d of y by x is x dy minus y dx upon x square, I was able to accomplish the result. Next question says what? It is asking you to compute the integrating factor of this differential equation. Let's do that. So obviously this is a linear differential equation, and that is why the question is asking us to get the integrating factor. I am going to rewrite this as dy by dx plus minus x upon 1 minus x square y equals 1 upon 1 minus x square. Dy by dx plus py equals q, where p and q is function of x. Integrating factor is e to the power integration of p dx, e to the power integration of minus x upon 1 minus x square dx. Let's separately see this. If I take 1 minus x square as t, This gives me minus 2x dx is dt, and I get x dx is minus dt by 2. So x dx will be minus dt by 2, and denominator is t. So you get minus 1 by 2 ln t. What you get? Minus 1 by 2 ln t, which is minus 1 by 2 ln of 1 minus x square, because 1 minus x square was t, and therefore what is it that you get? You get minus root over 1 minus x square. No, ln of, this is ln of minus root over 1 minus x square. Why? Because minus 1 by 2 is going to go over here. Let me say 1 by 2 is going to go over here. That is going to be 1 minus x square to the power 1 by 2, which is root of this, and this is going to be minus ln this. Now the moment you plug this value again over here, you have e to the power. This complete integration is this, minus into minus becomes plus. You are left with ln of root over 1 minus x square, which is obviously root over 1 minus x square. And therefore your answer is option number C. Clear? Very, very easy, direct, very computation of the integrating factor. Orthogonal trajectories. Okay. So the orthogonal trajectories of the family of curves given by y equals cx square. Okay. So what is the way to actually compute the orthogonal trajectories? Y is given to be equal to cx square. Differentiate both sides with respect to x. You get this. From here get the value of c, it is 1 by 2x dy by dx. c is 1 by 2x dy by dx. Plug this value over here, you get y equals 1 by 2x dy by dx into x square. This gives you x by 2 dy by dx, that is 2y equals x dy by dx. Now this is the differential equation which is representing this family of curves. I don't want the differential equation, I want the orthogonal trajectory. So the algorithm says that once you have the differential equation representing the family of curves, replace dy by dx by minus dx by dy. So you are going to get minus dx by dy. So from here you get 2y dy equals minus x dx, integrate, you get y square by 2, so 2 gets cancelled, equals minus x square by 2, right, plus c, so this gives you 2y square plus x square. Why? Because I bring it over here, I get 2y square plus x square equals 2c. Let's see. 2y square plus x square equals 2c. This is the very equation for the orthogonal trajectories of the family of curves represented by y equals cx square. Simple algorithm, I just applied the algorithm and got my answer. So if the algorithm is not clear to you, you won't be able to accomplish the result. Next question says the degree of this differential equation is what? Now see, in a bit complex form this particular differential equation is given to you, but this differential equation is actually representing the series e to the power x. E to the power x is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. In place of x there is dy by dx, and therefore I can write this as x equals e to the power dy by dx. Taking log both sides, I get log x equals log of e to the power dy by dx, which is just this. And clearly you can see this is a differential equation of degree 1, and therefore answer is this. Just keep in mind that e to the power x is 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on. In place of x, if I put dy by dx, I get the exact same thing which is written over here. Fine. Now I have the next question, which is that the differential equation of all circles. Now special type of circles are there. They are passing through origin and their center is lying on the y-axis. So if a circle is passing through the origin and the center is lying on the y-axis, how is my center going to look? 0, a, x coordinate will be 0. If the center is this, and you can see from here to here the distance is also a. So the radius is a and the center is 0, a, equation of such circles will be represented by what? X minus 0 whole square plus y minus a whole square equals radius square. Now once you have obtained this, differentiating both sides gives you 2x, or let me not differentiate it right now because this equation can be simplified further. So simplify it, you get x square plus y square plus a square minus 2ay equals a square. So you get x square plus y square minus 2ay equals 0. Now differentiate, you get 2x plus 2y dy by dx minus 2a dy by dx equals 0. Now see, 2 gets cancelled from everywhere. I am left with x plus y dy by dx equals a dy by dx because 2 has got cancelled. Now I will divide by dy by dx. When I divide throughout by dy by dx, I get x into dx by dy, because 1 upon dy by dx is dx by dy. This gets cancelled, I am left with just y, and here you have a. Substitute the value of a in star. In star you have a. Substitute the value of a in star, what you get is x square plus y square minus 2y. A is x dx by dy plus y. This is 0. From here you get x square plus y square minus 2y square plus y square gives you minus y square, and minus 2xy dx by dy equals 0. If you divide throughout by dx by dy, you get x square minus y square dy by dx minus 2xy equals 0, and that's your answer. Yes, you have x square minus y square dy by dx minus 2xy equals 0. This is the differential equation of all circles which are passing through origin and the center is lying on the y-axis. In this case, the y coordinate of the center will be equal to the radius. That is the only drill present. Once you have decoded that, you just differentiate, find out a, replace back a, and you have your answer. Because you want to get rid of this unknown factor, this parameter a, and therefore you are finding out the value of a and replacing it back so that the unknown parameter is no more present. Next question, let's see what is it. So, I have the next question, the orthogonal trajectories again, okay. So, orthogonal trajectories of the family of curves a n minus 1 y equals x to the power n. Convenient is to first of all take log both sides. When you take log both sides, log of m into n gives you log of a to the power n minus 1, which is n minus 1 log a plus log y equals n log x. Now when you differentiate, this becomes 0 because it's constant. This becomes 1 by y dy by dx equals n by x. This is the differential equation of the family of curves represented by this equation. I want orthogonal trajectory, so I will be replacing dy by dx by minus dx by dy. So minus dx by dy, and now I will be integrating. So minus x dx is equal to ny dy. Integrate, you get minus x square by 2 equals ny square by 2 plus c. So you actually get ny square plus x square equals 2c, you can say, right? Ny square plus x square equals 2c. Ny square plus x square equals 2c, 2c is constant, and that's your answer. Easy enough? Again, I just followed the algorithm and I got the solution. Next question is what? It says if this is the solution of this differential equation and y of 0 is minus 1, then y of 1 is equal to what? Let's calculate. So this is what? Again you can see this is a linear differential equation. Write it in the standard form. dy by dt plus minus t upon 1 plus t y equals 1 upon 1 plus t. This is p, this is q, which are functions of the independent variable t. Integrating factor is e to the power integration of minus t upon 1 plus t dt. Let's separately calculate. Minus is going to go out. Separately, if you calculate t upon 1 plus t, you can add 1 and subtract 1. This gives you t plus 1 upon t plus 1, which is 1, minus 1 upon 1 plus t. This gives you t minus ln of 1 plus t. If this integration is t minus ln of 1 plus t, you are actually getting e to the power minus t plus ln of 1 plus t. Right? Because minus sign was already present over here. This gives you e to the power minus t into e to the power ln of 1 plus t, which is just 1 plus t. If this is my integrating factor, what is my solution? Y into integrating factor is equal to integration of q. Q is 1 upon 1 plus t. Integration of q into integrating factor plus constant. This gets cancelled. You are left with y into e to the power minus t into 1 plus t equals integration of e to the power minus t is what? E to the power minus t upon minus 1 plus c. When you divide throughout by e to the power minus t, you get y into 1 plus t equals minus 1 plus c into e to the power t. You are given that y of 0 is minus 1. That means when t is 0, y is minus 1. So when t is 0, y is minus 1. T is 0, you are left with c. C has come out to be 0. Replace it back over here. I get y into 1 plus t is minus 1 plus 0, which is minus 1, which implies y is actually minus 1 upon 1 plus t. You are asked what is the value of y of 1. That means when t is 1, what is y? When t is 1, you get minus 1 by 1 plus 1, that is minus 1 by 2. Y of 1 in this case is minus 1 by 2. Clear? Moving to the next. Interval contained in the domain of definition of non-zero solutions of this given differential equation is what? Okay, so first of all we need to compute the solution of this differential equation and then see in the domain of the solution of this differential equation which interval is contained. So the differential equation is x minus 3 whole square into y dash, that means dy by dx, plus y equals 0. I want all x together and all y together. So I can say x minus 3 whole square dy by dx equals minus y. So dy by minus y equals dx by x minus 3 whole square. Now from here if you integrate, what you get is minus ln y equals, or let me write it as, let us first write it as dy by ln y, or dy by y. What is this? Dy by y plus, because I am taking it over here, dy by y plus dx by x minus 3 whole square is 0. So when you basically integrate, or even if you integrate by taking it to the other side by keeping a minus sign at some end, what you basically get is ln y equals minus of what? What is integration of x minus 3 whole square? You know this is x minus 3 to the power minus 2, right? Integration of this is x minus 3 to the power minus 2 plus 1 upon minus 2 plus 1. So this gives you negative of 1 upon x minus 3. So negative of 1 upon x minus 3, this is just this plus ln c. I can add the constant as ln c, not a problem. Now if this is minus of 1 upon x minus 3, minus minus has become plus, this is what I am left with. So I have ln y minus ln c, which is ln of y by c, equals 1 upon x minus 3. So y by c is e to the power 1 upon x minus 3. Y is coming out to be this. That means all the real numbers x, for all the real number x for which x is not equal to 3, this is a solution. Because if x is equal to 3, this becomes 1 upon 0, which is not defined. So domain of solutions of this differential equation it is all the real numbers minus this real number 3. Now which are the intervals, or which is the interval which is contained in this domain? 0 to pi. So 0 to pi contains 3. I don't want 3 to be there, because then if this is containing 3, this is actually going to not lie in the domain of solutions, because pi is 3.14. So 3 is there in this interval. This is not true. 3.14 comes before 2 pi, so 3 is there, and here also 3 is there, but here 3 is not there. Clear? So it is this particular interval which is contained in the domain of solution r minus singleton 3. Moving on to the next question, we have if dy by dx is y plus 3 and y of 0 is 2, then y of ln 2 is what? Let's see. So dy by dx is y plus 3. Okay, so dy by dx is y plus 3. This is pretty simple. Separate the variables. Integrate. You get ln of y plus 3 equals x plus c. Now you are given that y of 0 is 2. When x is 0, y is 2. So y is 2 when x is 0. So when x is 0, 0 plus c gives you c. At that time y is 2, so you get ln 5, you get c is ln 5. Put it over here, you get ln of y plus 3 equals x plus ln 5. Y plus 3 will be equal to e to the power x plus ln 5, which is e to the power x into e to the power ln 5, which is 5. Right? You are being asked that what is y of ln 2 when x is ln 2. When x is ln 2, e to the power ln 2 gives you 2. So you get y plus 3 equals 10. Y at that time is 7. Right? When x is ln 2, then you get y plus 3 equals 10, so y is 7, and that is your answer. That's how you tackle with the problems based upon this chapter. That's it from my side. Thank you.